Splicing a service cable that is not long enough for termination on the neutral bar and main breaker within a residential box is permissible under specific conditions, provided these conditions are rigorously followed. The primary reference for acceptable splicing practices is the National Electrical Code, specifically Section 110.14, which addresses electrical connections. This section of the code mandates that electrical connections must ensure a permanently reliable connection. The connections must be made with consideration for the materials of the conductors being joined. The connection should be suitable for the conditions of use, such as temperature and environment, and splicing must be done with approved methods and materials. Firstly, ensure the splice complies fully with 110.14. This means that the splicing method and materials used must be listed and labeled for the specific application and conductor types involved. The connection needs to be electrically sound, mechanically secure, and properly insulated to prevent any shorts or ground faults. Secondly, the splice must be accessible for inspection and maintenance. Accessibility is a key requirement in electrical installations to allow for future inspections, testing, and repairs. The location of the splice must not be concealed in a way that would require permanent demolition of building finishes to access it. Access can be achieved through the use of junction boxes with removable covers or other approved enclosures that provide clear and unobstructed access to the splice. Thirdly, protection from physical damage is crucial. The splice must be housed in an enclosure that provides adequate protection against environmental factors, physical impacts, and other conditions that could compromise the integrity of the connection. This enclosure should be made of a durable material that is suitable for the location, such as metal or non-metallic materials that are resistant to corrosion and physical stress. Fourthly, confirm that the use of a splice is not prohibited by any other applicable codes or standards. While NEC 110.14 provides general guidelines for splicing, other sections of the code or local amendments may impose additional restrictions or requirements. It is essential to consult the local electrical code and any relevant standards to ensure compliance. Fifthly, always consider the ampacity of the conductors. The splice must not reduce the ampacity of the original conductor. This means that the splicing method and materials must be capable of handling the same amount of current as the conductors being spliced. This is generally addressed by using connectors and splicing techniques that are rated for the appropriate conductor size and material. Sixthly, use appropriate connectors and tools. The use of the correct connectors and tools is essential for making a reliable splice. The connectors should be listed and labeled for the specific conductor types and sizes being spliced. The tool should be properly calibrated and used in accordance with the manufacturer's instructions to ensure a secure and effective connection. Seventhly, proper insulation is critical. The splice must be properly insulated to prevent any electrical shorts or ground faults. This can be achieved by using listed and labeled insulation materials, such as heat shrink tubing, insulating tape, or other approved methods. The insulation should be applied in multiple layers to ensure complete coverage and protection. Eighthly, grounding and bonding requirements must be maintained. The splice must not compromise the grounding or bonding of the electrical system. All grounding and bonding conductors must be properly connected and secured to ensure a continuous path to ground. This is essential for safety and to prevent electrical shock hazards. Ninthly, document the splice location and details. It is good practice to document the location of the splice and the materials and methods used. This information can be helpful for future inspections, maintenance, and repairs. The documentation should include a clear description of the splice location, the date of the splice, the materials used, and any relevant information about the installation. Tenthly, consider the long-term reliability of the splice. While a splice may meet all of the code requirements, it is important to consider its long-term reliability. Factors such as corrosion, vibration, and thermal expansion can affect the integrity of the splice over time. Therefore, it is important to use high-quality materials and methods that are designed to withstand these conditions. In many situations, running a new service cable from the meter pan to the residential box is the preferred approach. Replacing the entire cable eliminates the potential risks associated with splicing and ensures a continuous, uninterrupted conductor. However, if running a new cable is not feasible due to physical constraints, cost considerations, or other factors, splicing the service cable may be an acceptable alternative, provided all the aforementioned conditions are met and properly implemented. When evaluating the feasibility of splicing versus running a new cable, consider the following aspects. Assess the existing conditions. Evaluate the condition of the existing service cable. If the cable is old, damaged, or deteriorated, it may be more prudent to replace it entirely rather than attempt to splice it. Consider the accessibility of the cable run. If the cable run is difficult to access or navigate, running a new cable may be more challenging and costly than splicing the existing cable. Evaluate the load requirements. Ensure that the existing service cable is adequately sized to handle the electrical load requirements of the dwelling. If the cable is undersized, it should be replaced with a larger cable rather than spliced. Consult with a qualified electrician. It is always recommended to consult with a qualified electrician to assess the situation and determine the best course of action. An electrician can evaluate the existing conditions, assess the load requirements, and ensure that the splicing or replacement is done in accordance with all applicable codes and standards. Furthermore, consider the specific requirements of service entrance conductors. Service entrance conductors, which run from the service point to the service disconnecting means, have specific installation requirements outlined in Article 230 of the National Electrical Code. These requirements address issues such as conductor size, overcurrent protection, and disconnecting means. The splice must not compromise any of these requirements. Splices in service entrance conductors should be avoided whenever possible. The NEC generally discourages splices in service entrance conductors due to the increased risk of failure and potential hazards. However, if a splice is necessary, it must be done in accordance with the code requirements and with the approval of the local electrical inspector. The location of the service disconnect is also important. The service disconnecting means must be readily accessible and located at a point where the service entrance conductors enter the building. The splice must not affect the accessibility or functionality of the service disconnect. Additionally, proper labeling and identification are crucial. All electrical panels and equipment must be properly labeled and identified to indicate their purpose and function. The splice should be clearly labeled to indicate its location and the date of the splice. This information can be helpful for future inspections and maintenance. The National Electrical Code provides specific guidelines for labeling electrical panels and equipment, including the use of durable labels and clear, concise language. Ensure that all labeling requirements are met to maintain safety and compliance. Remember, safety is paramount. Electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from electrical shock hazards. Always to energize the circuit before working on any electrical equipment, and use appropriate personal protective equipment such as gloves and eye protection. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Lastly, always verify your work. After completing the splice, thoroughly inspect the connection to ensure that it is secure, properly insulated, and free from any defects. Test the circuit to verify that it is functioning properly and that there are no electrical shorts or ground faults. If you have any doubts about the safety or integrity of the splice, consult with a qualified electrician. By following these guidelines and taking all necessary precautions, you can ensure that the splice is done safely and in accordance with all applicable codes and standards. Running a new service cable is generally preferable, but carefully executed splicing is acceptable when a full replacement is not feasible. Always prioritize safety and compliance with electrical codes.